Good afternoon, and welcome to today's presentation, Increased Productivity with Sustainable Non-Destructive Cleaning. Food processors will learn how to clean, sanitize, and disinfect without wiping, rinsing, corrosion, or use of any harmful chemicals that could contaminate food. My name is Kari Imberg, and I am the Associate Editor for Food Manufacturing. I'll be moderating today's webinar. Without any further delay, I will turn things over to our first speaker, Tyson Marlowe.
Thank you, Kari. I'm excited to talk to you today and thank Food Manufacturing for this opportunity to speak to all of you about some interesting ways to clean and sanitize in the food manufacturing industry. I'm going to talk about dry ice blast cleaning. So first, what is that? Well, it's sort of like sandblasting or any kind of media type blasting. We propel particles of dry ice with compressed air. Dry ice is the media. Those particles then impact upon the surface to clean. The most unique feature of using solid CO2 or dry ice is its ability to sublimate, meaning that it goes directly from a solid to a gas on impact. So we're repelling particles of dry ice at high speed to impact the surface, where then they just turn to gas and disappear. There's a number of benefits to doing this. First, it's typically faster than traditional cleaning methods. I'll talk more about, or we'll go through some examples later. Traditional methods are usually by hand because there's not a better way to clean. Cleaning with dry ice is sort of the ultimate clean-in-place tool. It's a cleaning tool that you can take to the machinery and clean with very little or even no disassembly. So less downtime, of course, means more runtime, but we can clean things in place, in line, while they're hot, all sorts of different situations like that. We can get a cleaner clean than cleaning by hand in many situations because we can get into tight spaces with precision. Also, there's no residue left behind by the dry ice. So if I were to use a chemical or something like that, I might have to rinse. That's not the case with dry ice. There is no residue left behind. Also, dry ice is a sustainable cleaner and also a non-destructive cleaner because it's not abrasive on metal. So the stainless steel or different types of metals that are used in the food manufacturing process will not be damaged by dry ice. In fact, we can even do some very delicate cleaning, things like cloth conveyors and different things like that. But it will not etch, profile, or scratch or even polish metal. I can blast clean all day on stainless steel and it's not going to change the surface. It is a dry process, so people that require that, we see this a lot in the food industry and flour mills, confectioners, chocolate manufacturers, things like that. They like it because it's a dry clean. We can clean in cold room environments because it's a dry clean. So that's a big benefit. Also, it's environmentally friendly. Because it disappears on impact, that means there's no secondary waste stream. If I clean with water, I have contaminated water I have to deal with, as all of you are probably painfully aware. So in a lot of situations, I can altogether eliminate chemicals, but in most situations, I reduce them drastically. It is non-toxic and food safe. Almost all of dry ice that's manufactured in the world is used as some part of a cold chain management to keep food cold. A small percentage of it is used for blast cleaning, although it's a very rapidly growing segment. Also, dry ice, the dry ice that we use to clean is recycled CO2. Some of you may ask, CO2 is a greenhouse gas. How is that environmentally friendly? Well, we simply harvest the CO2 off of some other process. I'll talk about that more in just a second. But we essentially recycle it. We aren't creating any CO2. We're just taking it from one form to another and then returning it back to that form. So a little bit more specific on how it works. It's a little bit different than sandblasting or soda blasting or some of those different types of media. It has a few different effects in the cleaning mechanism. The first, there is some kinetic effect or impact energy. The equation for kinetic energy is half times mass times velocity squared. This actually becomes important a little bit later as we talk about different types of dry ice because we can use different types for different different applications. But the particle itself of dry ice, no matter the size, is not very hard compared to other types of media. So we have to get it moving pretty fast. We take advantage of the velocity side of the equation. So typically, under normal pressures and in normal situations, we're moving the particles between 600 to 900 feet per second, so 200 to 300 meters per second. Dry ice is 109 degrees below 0 Fahrenheit, or about minus 79 Celsius. So it's cold. It's going to cool the contaminant. If you look on the slide here, you can see the contaminant represented by a red line and the particles of dry ice coming in. It's going to cool that red line or that contaminant faster than the substrate. So it's going to cause it to cool rapidly, shrink, and disbond. Then there's a gas expansion effect. When those particles hit the surface and go from a solid to a gas, when they sublimate, they expand about 800 times. So with these three things going on here, you have the impact energy, you have the thermal shock effect, and then gas expansion, which is actually lifting the contaminants off kind of from the inside, kind of like little explosions on the surface. And all the while not damaging the substrate. We can clean some very delicate things. This slide actually shows Mohs hardness scale for minerals. So this is a basic 1 to 10 scale, with talc being the softest, diamond being the hardest on this scale. I have in there showed some other types of media that we would commonly use to blast clean with: baking soda, corn cobs, garnet, aluminum oxide, different things like that. Dry ice is the only one of these. First, you can see it's very soft compared to the others, but it's the only one of them that will disappear, and it is a lot less abrasive than the others. So these other medias will tend to pit or damage the surface, scratch the surface of what you're trying to clean. Dry ice can be very delicate. A little bit about dry ice. Some of you may not be familiar with it. It comes in a lot of different forms. You'll see it in block form, or cut into slabs, or even pressed into slabs. It comes in the form of what I call nuggets. Really, pellets or nuggets from 1 millimeter in diameter up to 19 millimeters in diameter. Typically used in food cooling. The blasting dry ice is typically either 3 millimeter dry ice or blocks of dry ice that are shaved into very small sugar-like particles. There are some machines out there on the market that will use any form of dry ice, but typically it's either 3 millimeter pellets, which looks like rice, or blocks or slices that are shaved into sugar-sized particles. Pelletized dry ice is made on a machine like this. It looks like it's called a pelletizer. Industrial gas companies, the Air Gases, Praxairs, Lindy's, Air Liquides of the world have these machines, and they use them to make dry ice. Typically, they set up right next to some sort of refining process where they're making ammonia, fertilizer, or they're refining ethanol, or some sort of refining where they are producing CO2 as a byproduct. The industrial gas company will set up right next door. They'll pipe the gas over. They will turn it into liquid to store it, and then they'll put that liquid through a machine here that looks like this pelletizer. That liquid is then turned into solid dry ice, extruded through one of these dies. You see them in the middle of the slide here, of course, different sizes. And it's extruded, kind of looks like a pasta maker. Pelletized dry ice, 3 millimeters, typically looks like rice, something like that. They're very dense particles. We also can use block dry ice. It can either be made at the manufacturer, it can be cut later at the distributor, or it can be reformed anywhere from pellets or nuggets or other pieces of dry ice. When you shave dry ice, you get much smaller particles. We call them microparticles. They're typically 0 to 0.3 millimeters in diameter. And this is the sort of thing that you can use to clean very delicate things around wiring without damage. I could take ink off of a business card without punching through the paper. I can get quite delicate with it, without damaging the actual conveyor itself. So there are machines that are dedicated to 3 millimeter pellet blasting. They're used in a variety of industries, but typically they will be on wheels and mobile. They will have a hopper of dry ice, usually between from 30 to 80 pounds, something like that. They'll have some insulation properties and some agitation designed to keep the dry ice flowing. Because dry ice is so cold, it can, if left out, gather some moisture out of the air, or condense moisture out of the air and freeze it into water ice. And it can freeze into a solid block. So you have to keep those pellets isolated, agitated, and flowing through. So you want to make sure that you have a good machine that's designed to do that well. Machines that use block, simply put a block inside, shave it, and then those particles are fed into the airstream. Again, some machines will take any kind of dry ice, so some are very versatile and can do blocks, nuggets, pellets, whatever you can put in them. So dry ice delivered, again, it's from an industrial gas company. They typically are delivered in containers of 500 pounds, although you can get larger. 500 pounds will last you in the neighborhood of 4 to 6 hours of blasting. Typical run rates are 2 to 3 pounds per minute on a pellet machine. On a block shaver, they can be much less, down to 0.2 of a pound or something like that. So depending on what you're doing, it can vary quite a lot on how much dry ice you use. It will be delivered in an insulated container owned by the dry ice company. They'll typically deliver full ones, pick up empties. They can be delivered right to the plant or factory, or right to a job site, or anywhere really. So these dry ice companies are used to doing this. It's sort of like a milk delivery. They deliver the full ones, pick up the empties. The shelf life is generally about a week for dry ice. It does disappear just in atmospheric pressure, and it also will start to turn soft. So generally you have about a 10-day shelf life from when it's manufactured, but it will get to you probably 2 to 3 days after it's manufactured. So generally you have about a week to use it. Again, it runs off typical plant compressed air systems. With the bigger machines, they run in ranges needing air from 50 to 175 cubic feet per minute of air, typically at plant pressures of 80 to 100 psi. So most plants and factories will have enough air to run these machines. If not, or service contractors who offer a cleaning business, or have a cleaning business to offer a cleaning service, will often use diesel compressors that are portable, and they can take them anywhere. It's really a pretty simple setup, and the machines are user-friendly. You just need a source of dry ice, a source of compressed air that does not have a lot of water in it, so some sort of drying system. Most factories or plants have that. If you're using a portable, you can buy portable air dryers. And then you just need a machine connected to that air compressor, and then you hook up a nozzle, point it at the surface, and blast clean. It's really quite simple. But it's typical for companies that offer these for sale or for lease or rent, that they will offer demonstrations, training, things like that. So that's pretty typical. Personal protective equipment. For the dry ice, you should wear gloves when handling it. It's not going to freeze your hand solid or anything if you touch it like liquid nitrogen would, but it is very cold, and you can get dry ice burns on the surface of your skin if you handle it without gloves. You will need eye protection for while doing the blasting. Particles could come back, or more commonly, the dirt that you're trying to remove will come back. Hearing protection, because we're using compressed air, you'll want that as well. So for the dry ice blasting itself, hearing protection, eye protection, and gloves. Depending on what you're doing, you may want to use a face shield if there's a lot of debris coming back, or maybe even a Tyvek suit or something if you're blasting something that's wet. One of the applications for us that's popular is cleaning printing presses, and they can be quite messy, as you can imagine, because of the wet ink and grease and different things like that. So operators will sometimes wear a Tyvek suit. They could be cleaning smoke damage. They could be doing fire restoration, so maybe they'll wear a respirator. CO2 is not poisonous. Carbon dioxide is not poisonous, but it can displace oxygen. So if you're blast cleaning in a small room, or an isolated area, or somewhere that's lower than the regular shop around you because CO2 settles lower than regular air. You may want to use a CO2 monitor. In an open shop where there's regular air exchange, though, that is not a problem. The dry ice will, or the carbon dioxide will dissipate. So you really have to worry about it building up in small areas where you have a closed door and in small rooms, and you can easily ventilate to provide CO2 or to keep the CO2 from building up. We actually clean in a lot of different industries other than food and beverage, but a lot of because dry ice doesn't damage metals, we can clean in the plastic injection and rubber injection molding industries very well. We can open the presses, clean the tools while they're hot right on line, and then they can go right back into production. So we can do things a lot faster. You think of how many parts on an airplane or a car are made out of molded plastic or molded rubber or molded metal. In foundries we clean as well. So a lot of fabrication, a lot of molding applications. We do a lot of printing, power generation, anywhere there's buildup where they might want to clean things faster in place. A lot of historical restoration, fire restoration, mold remediation. A lot of companies out there use us as a cleaning tool. In the food and beverage customers, it's typically either on the food processing side, where they have hard to clean areas, where they have contaminants that are very difficult to remove, or they're in a difficult environment where they do not want to use water or can't use water. Dry ice is typically a good alternative. And then there's the packaging side, where you're dealing with, you could be dealing with printing, but you could be dealing with glue nozzles, labels on everything, package moving equipment, different things like that. We'll walk through some examples here in a minute, but so both on the processing and the packaging side, and most companies have a need for that type of cleaning. Usually, what we're replacing from a traditional cleaning method standpoint is water, some sort of chemicals, or cleaning it by hand, or meaning taking it apart or using scrapers, brushes, things that can be destructive on equipment. That will reduce your asset life and asset utilization rates, your scrap rates, and all of those sorts of things. I know water is used a lot in the food industry, and it's needed a lot in the food industry. If water is being used as a washdown cleaner, then it's probably not going to be a good replacement by dry ice. Dry ice is a line of sight cleaner, so you have to hit the surface itself with the particles of dry ice. There is no washdown effect like you would have with water. So it's more of the hard to get to places where you want to use dry ice to clean, and definitely where you're using chemicals or scrapers or wire brushes or soaps or things of that nature, where you have to do a lot of disassembly to get to what you're trying to clean. Here's a slide. I just put up some pictures of some typical applications in bakeries when things are dried on or carbonated or carbonized from being cooked, or if it's grease. It could be in hard to reach places where there's knives or some sort of conveyors or even chains. Chains are a good one in bakeries because you can't clean them with water or really chemicals. Dry ice does a really good job of keeping chains clean, and it's a dry clean, so it's not going to cause any rust or anything like that. It will remove all of the lubrication, though, and all of the dirt, so they do have to be relubricated. We see a lot of chain cleaning in bakeries, a lot of hard-to-reach areas where there's carbonized, baked-on grease or sugar or different things like that. A lot of conveyor cleaning, even while the conveyors are running. You can have dry ice cleaning even during production, and it can clean a conveyor. You can set it up to even clean across the conveyor as it's running. You can clean electric motors while they're running. I mean, think of how many electric motors you might have in a food manufacturing plant. If those motors are starting to, the cooling fins are starting to cake up with dust or maybe even ingredients that are mixing with moisture in the air and are clogging up those cooling fins. If you were to be able to clean all of those motors, you would probably cut your power bill significantly because those motors would be running more efficiently. So there are a lot of areas where you might clean with dry ice. Snack foods, we have just about every Frito-Lay in the United States using dry ice to clean on their Ashita weighers just before their packaging systems. You can see in these pictures the Ashitas where the chips come in with seasonings and grease and start to coat the weighers, and then they don't weigh correctly, so they have to be cleaned periodically. Typically, these were being cleaned by hand on a weekly basis. In this particular example, they were being taken all the way apart, disconnected from power, and as you can see in the example, their hand cleaning took 45 minutes per radial and about 4 hours per base. We were able to cut that down to just 15 minutes per radial feeder and 1 hour per base. There was some disassembly required, but a lot less. We didn't have to disconnect any of the wires or turn off the power or cover up sensors or motors or things like that. We can blast clean right on and around those things without causing damage. So it is a line of sight cleaner though. So if you have to clean behind something, you will have to remove it to clean it. So there might be some disassembly required, but typically it's a lot less. And as soon as these things are done being cleaned, they can be put back into production. You don't have to rinse them. You don't have to wait for them to dry, things like that. Packaging lines. So I kind of went there from food processing to packaging. Labelers are a really good example. This is at a bottling plant. You can see that hot glue gets really bad and built up on there, and then they have a shutdown on their assembly line, which is unexpected. That can cost a lot of money. Cleaning something like this, typically we were finding took around 5 to 6 hours to complete. People didn't like to do it because it wasn't a pleasant job. We could do it in about 45 minutes, and now you're talking. You can do more of a preventive maintenance type clean because you have time to do it. But again, you can put these things right back into production. You don't have to turn off the power, cover the sensors, things like that. Here's again another packaging. This is just in the bottling industry. This is putting syrup flavorings in a bag inside a box. So it's basically gluing a box around a bag. But you can see how nasty these glue nozzles get. Nobody wants to clean that. That's probably why they get that bad. In fact, when they do get the bad, you're really looking at replacing the glue nozzles instead of just cleaning them. But if you can clean them, you're going to spend a few hours doing it. We're going to cut that time at least, from 25 to 35% of what it used to take to clean. Here's an example for a denesser or pelletizer. This is what I was talking about stacking equipment. The old way to clean this would be to mask everything, all the motors and the sensors, disconnect from power, clean for 6 hours, and then let it sit for 24 to 36 hours to dry before you could put it back into production. With dry ice blast cleaning, you don't have to mask anything. Clean it in about 3 hours, particularly where there's labels and things. I see a lot of this in the food industry where labels are all over these stacking and conveyance systems. Dry ice really does well with adhesives and labels. It should take it right off. And I mean, we can do it and put it right back into production immediately. No need for waiting to dry because it's a dry process. So a lot of general cleanup we see in the food industry, from mold buildup on heat exchangers. Floor grates can get very nasty. I talked about electric motors before. You see the cooling fins getting a lot of buildup on them. We can make them run a lot more efficient, and we can clean them even while they're powered and running. You see a lot of flaking paint on ceilings and walls. We can clean off failed paint without adding any additional contaminant to your food plant. So that's just a few examples. So just as a review before I turn it over to Rob, the main advantages for cleaning with dry ice is when you have your current cleaning method is labor intensive. If you have to do a lot of disassembly in your current cleaning method, then that's usually a good indicator that dry ice could be a good tool for you. If you need to clean during production, dry ice can be a good tool there. Sometimes grit entrapment is a problem. If you have a printing, something that's printing labels or something like that, or glue guns, you have to avoid getting immediate grit entrapped in that equipment. Dry ice is good because it disappears. So if the surfaces have to be free of residue or contaminants, meaning At the end of the cleaning, if you have to do a lot of rinsing or waiting to dry or things like that, or water and chemicals are difficult to use, that's typically good for dry ice. Maintaining surface dimensions is very important. Dry ice is good because it's non-destructive on metals, so we can clean them, and many plastics and even softer things we can clean without damage. But anytime hazardous waste is a concern, typically dry ice can cut down on the amount of hazardous waste that you have, whether it's replacing some chemical cleaning altogether or at least supplementing it.
That concludes today's presentation. Enjoy the rest of your day.